In this video, we want to take a look at something called the complement of an event. First, I want you to notice the spelling here of complement. It's with an E, not an I. That's because it's connected to completing something, not saying nice things. So what is the complement of an event? Well, if my event is E, then the complement is the event E doesn't happen. Strange, right? So let's look at a specific case. If my event E is rolling a 6 when I roll a die, the complement of that is going to be not rolling a 6, which would also be the same as rolling a 1, 2, 3, 4, or 5. Now you can kind of see where that complete part comes in. Between that 1, 2, 3, 4, 5 and my original event E, that outcome of 6, that completes the sample space. So the probability of an event and its complement take into consideration all the possible outcomes, so together they would add up to 100% of the probabilities. We'll get back to that in a second. First, I want to give you some notation. In math, we always have notation. This is no different. So if my event is E, then E with a bar above it means the complement of that event. How do I use this to calculate probabilities? Well, the probability of event E is going to be equal to 1 minus the probability of its complement. Again, let's take a look at an example to help clarify this. Suppose we have 2 fair die that are rolled. We want to find the probability of not getting doubles. Okay, that's getting a 1 and a 2, a 2 and a 1, a 1 and a 3 and a 1, and so on. And we could sit here for a minute and write out all those possibilities, or we could think of the complement of this. What is the complement of not getting doubles? What's not getting doubles? It means we are getting doubles. I know it's a play on words, but the opposite kind of not getting doubles is getting doubles. You kind of think about complements as opposites. Well, that's pretty quick to list out. Doubles are 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So to calculate the probability of not getting doubles, we would take 1 minus the 6 over 36, getting doubles, which will reduce to 1/6, and that gives me a final answer of 5/6 probability. Okay, now I know fractions can be a little bit tricky for everyone, but you should have a scientific calculator that has a button and a feature on it to quickly convert that decimal answer that you get to a fraction. If you need help with that, let me know and we will talk it through. I just need to know specifically what calculator you have. I also want to show you that online there's Desmos calculators. They have graphing calculators, but they also have a scientific one that I'm going to use here. So you recall our problem was 1 minus 6 over 36, right? So in my calculator, I'm going to do 1 minus 6 divided by 36, and it makes it a fraction for me. Arrow out, and then hit enter. That gives me my answer here. It's in decimal form, 0.8333. But you notice right off on the side, there's this little button and it says convert this to a fraction. Yes, sir. So there we go, 5/6. All right, so if you need help with the calculator, let me know. Let's get back to this concept here. Let's try one more to see if you've got this. This one says you are dealt a card from a standard 52 card deck. Find the probability that you do not get an ace. What's the probability that you do not get an ace? Okay, let's see how you did. Well, there are 4 suits in our deck of cards, and each one of those has an ace, so that means there are 4 aces, right? So that means, let me scroll this down, probability of not getting an ace is 1 minus that 4 out of 52, or 1 minus 1/13, for a final answer of 12/13. Again, you can use your calculator to help with the fractions. Let me know if you have any questions.